Hello friends, welcome to my channel. Let's have a look at problem 12, integer to Roman. So this is a continuation for the video for problem 13, Roman to integer. So in this video, we're going to share a solution based on the division with remainder method. So the main statement is on the Roman number rules, so we are not going to read all this through. And this problem is asking that given a integer, so we want to output a Roman format. So the constraint for this problem is that the numerical number is bounded in between 1 and 3999. So with that said, so we are ready to analyze the problems. So the method is basically the division with remainder. So this is very elementary. So the Roman number rules are the following. So first, the set of atomic symbols are IVX, L, C, D, M. So I is 1, V is 5, and so on. M is 1000. Rule 1 is the following. We try not repeating an atomic symbol more than 3 times. For example, we have 3 like triple I, but in general, we do not write 4 I's together. But this last 4 I's sometimes is still used. So for example, in clock or watch. So rule 2 is that left small subtraction for this instances like IV, IX, or CM. So the left atomic symbol represents a small number, smaller number than the right atomic symbol. So the interpretation is that the right number minus the left number, that is 5 minus 1 equals 4 for IV. You can interpret other instances similarly. So rule 3 is right small addition. So for example, VI. So V is larger than I. So we add them together. So we get 5 plus 1. That is 6. So another rule is a bar or line above a number, which means multiply by 1000. But it's not relevant in this problem. For example, if we put a bar in M, it means 1000 times 1000, that is 1 million. So to solve this problem, the idea actually is simple. So a solution will be valid if we could take the above rules into consideration. So the above rules actually tells us how to do the transformation from one form to the other format. So among the above rules, rule 2 is a key point for this problem too. So all others are basically addition, right? So we just need to check if we have valid rule 2 cases in a valid Roman number, or in the process we transform a numerical value to a Roman representation. So basically we want to reverse the procedure for Leetcode problem 13, Rome to integer. So in that problem, we actually use a dictionary. So the key is the atomic symbols, and the value is the numerical values. So in this problem, we are going to use the numerical value as the key, and the Roman string as the value. Right? This is the dictionary we are going to use. So we're going to use division with remainder method. So we are checking divisors from large to small, and then we check how many repetitions, and then we just enlarge or concatenate the corresponding Roman representations. So here actually a sorted dictionary is a most suitable abstract data structure, but we shall use vanilla dictionary here and plus a sorting, because the dictionary size above is small and bounded by a constant. So here is an walkthrough. For example, if we have number 58, then the largest one, the largest one 50. So in this table, so if we do this division, so the quotient is not 0, right? So we have Q equals 1 and R equals 8. So Q represents the number of repetitions, and R is the remainder. So we have, because in this case we have an 1L, right? So then we do the division for 8 over 5. So we get quotient is 1 and R is 3. so we have LV. Then 3 divided by 1, we get Q is 3 and the remainder is 0, so we stop. So we repeat the 1 3 times, so that is a triple I. So we have LX, not LX, so it's LVII. That's the Roman representation for 58. That's example 2. So now with that said, we are ready to write the code. So as we mentioned, we're going to use this dictionary. Let's copy it here. So, and then we want to do a sort, because we need to check from larger to small. So we'll basically sort it. So for k in dict, so we're going to use reverse. So reverse equals true, or we can write a lambda function. So that's it. So in this case, we start from 900, then 400, up to 1. And next basically is for loop. So let's initialize an empty string, and then we do the for loop. So for value in list, then we're going to check the number of repetition, that is count, and the remainder, right? That is the division with remainder. So we're going to use the number as the dividend and the value as the divisor. So if the count is not 0, then we are going to do this. So we're going to concatenate the corresponding Roman string and the right number of repetition, that is count, to the result. So that is count times dict. So let me write this: dict value times count. And then we're going to, after this, so we're going to reset the number to be the R. So that's the full work. Actually, next we are just ready to return the result. So that's the procedure. So let's do a special case check first. So object is not iterable for dict. So here let's correct the spelling. So that's dict. So we get the first example passed. Let's do the second example, that is 58. So yeah, we passed the second example. Now let's do a generic case check. So it passes all the generic cases. So I guess that's about it for this problem. So it's good to compare the solution with problem 13. So notice that we use the dictionary in different formats, essentially reverse the key and value pairs in these two problems. So with that said, I guess that's about it for this specific problem. Thank you very much.